Okay, good morning everyone. Am I audible? Is the screen visible properly?
Yes, sir.
Yeah. So in the previous lecture, we started with tracing of the Cartesian curve. I have already introduced to all the techniques those are involved in tracing a Cartesian curve, and the uh, summary of all of it was whenever a Cartesian equation is given. So the first thing that we will do is we'll check the symmetry, as you can see it on the screen. In the symmetry, there are different types of symmetry. When the curve is symmetric about x-axis, when it is symmetric about y-axis, when it is symmetric about y equal to x line, and the fourth one about the pole. The next point that we need to check is point of intersection. So in the point of intersection, what I want to see is actually the curve intersects the origin or not. Does it intersect x-axis? Does it intersect y-axis? And whatever the points of intersection we will get, at those points, what I need to do is I need to find the tangent. So first of all, the tangent at the origin, the criteria to check whether a curve is how to find out the tangent at the origin is you equate the lowest power terms, the group of lowest power terms directly to zero. So what we will get is we will get the equation of tangent at the origin. Then at any intercept, we will find out by the derivative. The next is the asymptote. What do we mean by an asymptote is? Asymptote is nothing but the tangent at infinity. Whatever tangent we get at infinity, that tangent is called the asymptote. And how do we find it is? So we have two things. If the asymptote is parallel to x-axis, so what do we do in order to find the asymptote parallel to x-axis is coefficient of highest power of x to 0. So whatever highest power of x appears in the equation, you take the coefficient and equate it to 0. That is how we find out the asymptote parallel to x-axis. And the last one is the region of absence. So we convert it in either of the form and we see for which value of x y does not exist, or for which value of y x does not exist. So this is the last point that we need to do. So these are all the things. So in the today's lecture, we will start solving some examples. Example, trace the curve. Trace the curve y square in bracket 2a minus x equal to x cube. First of all, symmetry. Anyone? Which symmetry does it hold? You can see that the power of y is even. So whenever a power of y is even, our curve is symmetric about
Y-axis.
x-axis.
Exact.
X-axis. The curve is symmetric about x-axis. Symmetric about x-axis as power of y is even. As power of y is even. Second point, that is origin or the points of intersection. Points of intersection. So in points of intersection, what we simple idea is you put one of the variable 0. So if y equal to 0, then what do we get? X is equal to 0. This is nothing but the x intercept we are talking about. If we put y equal to 0, so what do we get? 0 comma 0. So only x-intercept. Then we'll talk about y-intercept. So if x is equal to 0, then what do we get is 2a into y square is equal to 0, which implies that again y equal to 0. So now the only point of intersection on x and y axis combined is 0, comma 0. So we'll talk about the tangent at origin. Tangent at origin. What was the criteria to find out the tangent at origin? You equate the group of lowest degree terms to 0. So let me just open the bracket. 2ay square minus x into y square is equal to x cube. So you can see that this is the term with power as 3. This is the term with power as 3. This is the term with power as 2. So the group of lowest degree term is 2ay square. So I will equate 2ay square is equal to 0, which means that y equal to 0. This is the tangent at origin. Y square is equal to 0 actually means that y is equal to 0, comma y equal to 0. So what more conclusion I can draw here? You have two tangents, y equal to 0, comma y equal to 0. So 0, comma 0 has to be anyone? If you remember our discussion, you have two tangents.
You're a
Both
node.
it is
Node.
node or cusp.
Or isolated point, right?
No,
2a minus x is equal to 0.
this is the cusp.
It is a cusp.
Two tangents, both are same. Okay. Now the last second point is asymptote. Asymptote parallel to x-axis. You can check this on rough. Okay, asymptote parallel to x-axis. What is the highest power of x appearing in the equation is x cube. What is the coefficient? 1 equal to 0. This is not possible. So what is the conclusion? Asymptote parallel to x-axis does not exist. So we'll go for asymptote parallel to y-axis. Parallel to y-axis. What is the highest power of y? Which is y square. What is the coefficient of y square? 2a minus x equal to 0, which means that x is equal to 2a. Now let's just try to sum up everything. There is one more point remaining, but I will suggest that every time whenever you're solving examples, you try to draw the curve here itself. Do all the sketching part, whatever things you have. First of all, symmetric about x-axis. So it is enough if I draw the curve in the upper two quadrants, 1 and 2. We won't look at the negative part since it is just the reflection about x-axis. Then the curve is intersecting only one point, which is 0, comma 0. This is the point of intersection. What is the tangent at this point? Tangent at origin is y equal to 0, which is nothing but x-axis. This is the tangent. Okay. This line is the tangent. Now, now we have the asymptote x equal to 2a. X equal to 2a is a line which is parallel to y. So this is the line x equal to 2a. At infinity, my curve is near this. I mean, it is going near to this line. And as it comes to 0, it is intersecting this point. So there are two ways this can be done. Like this or like this. I'll name this 1, 2. Which is the correct one? Which is the correct one? 1 is correct or second is correct?
The second,
Why?
because the tangent is x-axis, and for the first one, the tangent will be y-axis.
Yes, exactly. So this is how, I mean, you make a conclusion from the tangent. Okay. So that's why tangents are very important whenever we have the points of intersection, even asymptote. So depending on this criteria, this four criteria, 70% examples can be solved. Okay. Just for that 30%, we are going for the what you say, the region of absence. Now our curve is symmetric about x-axis, so I will simply take the reflection over here. Right now, we don't see anything on this side, the left hand side, and on the right hand side of the line x equal to 2a. So only that thing we will prove by the region of absence. So by region of absence, the region of absence. So in this case, what I will do is I will write down y square as x cube upon 2a minus x. So if you take x less than 0, then if x is less than 0, x cube will of course be negative, right? And denominator will become positive. So x cube less than 0, 2a minus x greater than 0. No value of, I mean, this is the region of absence. Once we get this, we can conclude that this is the region of absence. The region of absence. Now I will take x greater than 2a. If x is greater than 2a, then x cube is of course positive and 2a minus x will become less than 0. So even this is the region of absence. So what we have proved is our curve exists only in the region 0 to 2a. Is there any doubt? If yes, please ask, or else I'll go ahead.
Excuse me, sir.
Yes.
For midterm, we have polar
Beta,
parametric curves
let's
also.
let's stop this discussion. Uh, I said if you have any problem with this example, ask.
Sir, tangent and origin, how we have to take? I not understand.
That is the criteria we have seen in the previous lecture, which says that the tangent at origin is given by equating the group of lowest degree terms to 0. So here I have opened the bracket and I have seen that the first term is having degree 2, second term is having degree 3. The power of x is 1, the power of y is 2. So total degree is 3. The right hand side, the power of x is 3. So to find the tangent at origin, what we do is we equate the group of lowest degree term to 0. The lowest degree term in this is 2. So this complete group I have to equate it to 0. So 2a y square I have equated it to 0, which means that y equal to 0. Clear?
Sir,
Hmm.
sir, can you explain the construction of the graph once again? Like how to draw the graph?
I can explain it once again, but it won't make a lot of difference till you don't try it yourself. Just We'll solve one more example. In that, maybe you will able to understand. I won't draw the graph. I'll give you 2 minutes. Okay. So you try it
Yes.
on your own in that, and still I will explain the next one. Okay. So next example. Stress the curve x into x square plus y square is equal to a into x square minus y square. Symmetry
X-axis.
about x-axis. Next point, the point of intersection. So for the points of intersection, you put y equal to 0. What do we get is x cube is equal to a into x square. So when we solve this, we'll get x square into x minus a equal to 0, which means that x equal to 0 or x equal to a. So there are 2 points of intersections, 0 comma 0 and a comma 0. Now, if you put x equal to 0, you can see that you'll get this only point 0 comma 0. So I won't go for it. Let's talk about the tangent. So tangent at origin, let's open the bracket, x cube plus xy square is equal to a x square minus y square. What do we see? The group of lowest degree terms. This is degree 3 term. This is degree 3. Both are of degree 3. And these two are of degree 2. So the group of lowest degree term is the right hand side. So I will equate that complete term to 0 in order to get the tangent at origin. So x square minus y square is equal to 0, which implies that y equal to plus minus x. So there are two tangents at the origin, y equal to x and y equal to minus x. Both are distinct. So this point is going to be node. Then we have to talk about the tangent at the point a comma 0. So for that, what we will do is we'll take the derivative of this. So differentiating. Okay. So what we have is x cube plus x into y square is equal to a into x square minus a into y square. So derivative of this is going to be 3x square plus x into 2y dy by dx plus y square is equal to 2ax minus 2ay dy by dx. We can separate this. So 2xy plus 2ay dy by dx is equal to 2ax minus 3x square minus y square. So dy by dx is equal to 2ax minus 3x square minus y square divided by 2xy plus 2ay. What do you see if I take this at a comma 0? What do you get? You put x as a and y as 0. So what will be the value? This will go infinity. As you can see that denominator, both of the terms have y. So as both of the terms have y, we will have 1 upon 0, which is infinity. So what is the conclusion at the point a comma 0 about the tangent? Tangent is parallel to y-axis as the derivative is becoming infinity. Okay. Then let's talk about the asymptote. Has anyone worked out with the asymptote? Please try to do it. I'll rub this part and I will simply write down dy by dx at a comma 0 is equal to infinity. So as dy by dx at a comma 0 is equal to infinity, tangent at a comma 0 is parallel to y-axis. That's one asymptote. Parallel to y-axis. Highest power of y. What is the highest power of y? Which is y square. We will have to collect the coefficients. So x cube plus x into y square is equal to a into x square minus a into y square. Let's take this on the other side. X cube plus xy square plus ay square is equal to ax square. So x cube plus x plus a into y square minus ax square equal to 0. Equate the coefficient of highest power of y. What is the highest power of y? 2. And what is the coefficient? X plus a. So equate x plus a to 0. What do we get? X is equal to minus a. So there is an asymptote which is parallel to y-axis. Okay. Now you have 2 minutes. By the time I will rub this, Sumed,
Yes, sir. Hello.
try to draw the curve.
Yes, sir.
Uh, Look, the questions or the MCQs, the kind of MCQs you can actually expect is that okay, a curve may be given, find the tangent at origin. So what is the asymptote for this? Then what is the region of absence for a given curve? What is the symmetry for the given curve? So this big example can be brought in small examples, and that is how MCQs can be asked in this. Yes. If someone is done with drawing the curve, I can go for this then. Sumit, you have got anything?
Sir, sorry, sir, I'm unable to like figure it out how to like start and.
Okay. Anyone else? Just a raising hand would
Will
be
it be
fine.
in shape of a knot?
What you said, Abhishek?
Will it be like a shape of a knot, like
Yes, yes, exactly. You're right. So I draw the curve now. Everyone, please concentrate how I'm doing it. First of all, plot the things that you have. So for an example, our curve is symmetric about x-axis. So I will just draw the above curve. Okay. Then point of intersection. Please mute yourself, whoever it is. Mr. Mayur, will you mute yourself? Zero zero, and then the point a comma 0. This is the point a comma 0. So curve is intersecting these 2 points. Then the tangent at the origin are, there are 2 tangents at the origin. One is like this, the line y equal to x, and the other is like this, y equal to minus x. Then at the point a comma 0, the tangent is vertical. Okay. Then we have the asymptote, which is x equal to minus a. X equal to minus a is actually a line here. This is x equal to minus a. Now let's join everything. So at x equal to, what do we mean by an asymptote? Asymptote is nothing but the tangent at infinity. So at infinity, my curve is near this line x equal to minus a. So it must come from here. The curve must start from here. Okay. And then my curve is intersecting this origin. But how it is intersecting? It is intersecting like this line must become tangent, the y equal to minus x. And then after this, it must intersect a comma 0. But intersection is like this. Okay, because the vertical line has to be tangent. Okay, if vertical line has to be tangent, the curve must go like this in a round manner. Then my curve is symmetric about x-axis. So I'll simply take the reflection. Okay. Now there are 2 things to check. What happens when x is greater than a? What happens when x is less than minus a? So from the given equation, you can show the region of absence in this. to show the region of absence. It'll take y square equal to something. Okay, so we'll have to convert the given equation in such a manner that we'll get y square equal to something. So from this equation, I guess I can do that. When you open the bracket, what you will get is x plus a into y square. So y square will be equal to a into x square minus x cube upon x plus a. So from this, you put x greater than a, x less than minus a, and you can show that. Fine. Anyone who has problem or still it is not clear to you? Sumit, is it clear?
Yes, sir.
Okay, everyone just try one example then. X into y square is equal to e square a minus x. Try to do it. Yes, we go fast. It is symmetry about
x-axis.
x-axis intersection
X is equal to a.
x equal to a.
Yes, sir.
No, point of intersection.
X is equals to A.
A comma
At
0.
x
A
equals
comma
to a.
0.
A comma 0.
A comma
Tangent at
0.
a comma 0 is Parallel to
y-axis.
y-axis. Asymptote.
So asymptote parallel to y-axis.
Yes. And what is the equation?
X is equal to 0.
Yes. X equal to 0. So has anyone traced the curve?
Sir, I have a doubt.
Yes.
Yeah, sir. In this example, the tangent and the asymptote are the same. So
No, 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 no.
how will we?
Tangent you are talking about, you will have to talk about the tangent at origin. And we are not exactly finding out the equation of a tangent. What you have done is you have took dy by dx and you have put checked at a comma 0. And it says that it is infinity. So what conclusion you get is if the dy by dx at a comma 0 is infinity, it will mean that the tangent is parallel to y-axis. We don't have the equation. Am I clear? Yes. Yes, am I clear? You are not finding out the tangent. You are checking the nature of the tangent at a comma 0. And what nature you have concluded is the tangent is parallel to y-axis. That's it.
Okay, sir.
Hmm. So is there anyone who have traced the curve?
So the whole curve will only touch at 0, comma 0, but it will be tangent to y-axis. So,
Okay, anyway, your call. You may try to do it or you may not. I'll complete my task. So
So the
tangent
curve
curve intersects the point a comma 0. At this, the tangent is parallel to y-axis. This line is the tangent. This is the y-axis. We can see that the asymptote is x equal to 0. So at infinity, the curve goes near to this. It must intersect this point and it should intersect in this manner as the tangent is parallel to y-axis. Now the curve is symmetric about x-axis, so I will reflect it in the negative direction too. This is how my curve is. Now it's your task for the region of absence. What you show is for x less than 0 and for x greater than a, curve does not exist. And to show that, we will have to convert the equation to the form y square is equal to a square a minus x upon x. This will be the region of absence, and this is how you will show it. Fine. So the next type of curve that we need to see is the polar curve. I'll just start with basics of this because polar coordinates are something we are not much familiar with. And in the polar coordinate system, each and every point in a plane is identified by r comma theta. What is r? R is the distance from origin, which in vector, which can also be treated as a vector. Okay, this can also be treated as a vector. So that is going to be the vector which is starting from the origin and ending at a certain point. And what is theta? Angle made with positive x axis. Angle made with positive x axis. So whatever angle it will make with positive x axis, that will be theta. So polar coordinate runs around this r and theta. Now I will give you two equations. The first one, r equal to 2. And the second one, theta equal to pi by 2. What are these? Geometrical figures. Okay. So r equal to 2. How do you identify a geometrical figure? You take all the points in a plane which are having the value of r as 2. Yes, anyone?
So circle
It would make a
having
circle.
center at origin of radius 2.
Yes, exactly. So this will be a circle of radius 2 units. Okay. So r equal to a constant number, this represents a circle in polar coordinates. What about theta equal to pi by 2?
Represents a line
Lines parallel to y-axis.
parallel to y.
Exactly. So theta parallel to y-axis, are you sure?
On the y-axis.
Simply y-axis.
Y-axis.
Simply y-axis. So theta equal to pi by 2 is a straight line. Not just this, you give any constant value to this theta. Say for an example, theta equal to pi by 4. This will be the line y equal to x, this one. So theta equal to constant number represents a straight line. Okay. So in polar coordinate system, the equation of tangent, if you are finding, tangent is a line. So you will always get theta equal to constant number that will represent a tangent. Okay. So these are some things that we needed to think of before we start with polar coordinate systems and polar curves. So in the next lecture, we will see the theory of the polar curves as well as we'll solve some of the examples. That's all for today. If you have any difficulty in this, please ask. Put up your attendance. If there is any question you want to ask related to midterm now. We have lecture till 27th, right? Vishal?
No, sir. Yeah, 27th is our exam.
Yes,
27th को exam है.
Yes, sir. 27th से 31st तक का डेट दिया है.
अच्छा. ठीक है.
4 days है सर एग्जाम.
अच्छा. I will have to conduct extra lecture on Wednesday. Fine. Okay, put up your attendance. I'll disconnect the meeting now.